And welcome to Sonoran Sky Live. I'm meteorologist Pete Mangione. Today we are going to be talking about ENSO. So you might be wondering, what is ENSO? Well, ENSO is the El Nino Southern Oscillation. This is basically when we talk about things like La Nina and El Nino. Now for the next 30 minutes, we're going to be talking more about La Nina because we're in a La Nina right now, and there's a chance it will at least be sticking around for part of the winter. We're going to bring in a few experts in just a couple of minutes, but I just want to give you a brief intro on what we mean when we're talking about La Nina. So La Nina is a global circulation pattern, and it's one of the best, if not the best, predictors of longer-term weather. It doesn't mean it's perfect, but it's one of the best long-term predictors that we have when trying to describe the weather over the next several months or even the next season or two. So let's look at what happens when we are in a La Nina like we are in right now. Okay, so we have these things called trade winds. They blow from east to west along the equator. Now, there are certain times when these trade winds will get going stronger than normal, and that's what happens during a La Nina. What that does is it pushes this warm water off the equatorial coast of South America. You can see the U.S. is here, here's South America. It's going to push that warm water to the west, and then we get this thing called upwelling happening. So that means the cold water rises to the surface, and then we have water which is cooler than normal sitting in this part of the Pacific Ocean. Now, when we have this kind of condition that sets up, this affects jet streams, global circulations. One of the things it tends to do is create this weather pattern in the winter. When I say tends, it does not mean this is exactly what happens every single La Nina winter, but this is what happens more often than not. And this is what a lot of the forecast models and forecasters use to try to make predictions when we're trying to forecast winter when we're still at the very beginning of winter like we are right now. So you can see in general, La Nina tends to be kind of cool and wet in parts of the northern United States, including the northwest, parts of the Great Lakes. And it tends to be drier and warmer than normal in the southwest and a good part of the southern U.S., including here in Arizona. And just to give you a little bit of a local perspective, this is a look at Flagstaff snowfall over the past 4 La Ninas. I think this is a great example of how La Nina shows what tends to happen, but not what always happens. So the past 4 La Ninas in Flagstaff, we're looking at winter snowfall. You can see last winter, 24-25. I don't want to insult 24-25, but this is just pathetic. 8.5 inches of snow, really? So that was not a great snowfall year for Flagstaff last winter. But look at the La Nina of 22-23, well above normal. By the way, normal Flagstaff is around 58 inches of snow. We had 115 inches of snow the winter of 22-23, but then the 2 La Ninas before that, 21-22 and 2021, well below normal. So again, you can see what happens here. The La Nina winters here in Flagstaff and parts of Arizona tend to be below normal for precipitation and snowfall, but not always. All right, I want to bring in our guests right now. They are actually experts in forecasting El Nino and La Nina. I'm going to introduce Nat Johnson. By the way, he's a good friend of mine from grad school at Penn State, so that's the first thing I want to point out. But he's also a NOAA meteorologist at the Geophysical Fluid Dynamics Laboratory. And then we also have Emily Becker. She's a research associate professor at the University of Miami Rosenstiel School. Welcome to you both.
Thanks so much for having us.
All right, Emily, let's start with you. Can you just briefly introduce yourself and your role in forecasting ENSO, La Nina, and El Nino?
Sure thing. It's great to see you again, Pete. It's been a while. I have been part of the ENSO forecast team at NOAA's Climate Prediction Center for about 10 years now. For the last 6 years, I've been based at the University of Miami, so I'm sort of an ex officio forecaster for the ENSO team.
All right, Emily, thank you so much. And Nat Johnson, why don't you introduce yourself and your role in forecasting ENSO?
Great, thanks, Pete. Yeah, I'm a meteorologist at the NOAA Geophysical Fluid Dynamics Lab. I've been here since late 2014, and I joined the ENSO forecast team in 2017. And ever since then, I've been one of the regular forecasters contributing to the seasonal ENSO outlooks each month.
Fantastic. All right. I'm going to ask my crew here, am I allowed to walk over to the other monitor during this interview? Yes, I am. All right. This is what I like about live streaming. We can kind of just do things on the fly here. So behind me, while I'm going to talk to you, we have what typically happens during La Nina. So Nat, or Emily, I'm going to start with you. I'm sure you probably know my first question. What is the latest info on the forecast for La Nina this winter?
So we're going to have to keep you in a little bit of suspense because the official forecast comes out on Thursday. So I can really only talk about the forecast from last month. But that is that we are currently in a weak La Nina conditions, and that La Nina is anticipated to hang around for a couple more months before dissipating and turning back into what we call ENSO neutral conditions. So neither La Nina nor El Nino. And in terms of this upcoming forecast, I guess a little sneak peek would be that we don't have any reason to anticipate a large deviation from last month's forecast.
Emily, I love getting like the inside information here a few days before the official forecast comes out.
It comes out on Thursday,
Right.
and we cannot let it slip. But I can talk about last month's forecast, as I said.
Totally understand that. I mean, I have that drilled in my brain now that the second Thursday of each month, that's when the new ENSO update is in. All right, so Nat, we're going to go over to you now. So starting in 2020, we had 3 consecutive La Nina winters. This past winter, I'm not sure if it technically counted or not, but I know briefly we were at least in a La Nina phase. Is there a reason we're seeing so much La Nina lately?
It's a great question. I think it's something that the research community is looking into. So, first of all, yeah, you're right. We've seen a lot of La Ninas, and moreover, when we do have a La Nina, we tend to have it lasting for 2 or even, as you mentioned, 3 years in a row. And actually, if you look back at all the La Ninas over the last 50 years, I think almost all of them have lasted for, I've been at least 2-year La Ninas and sometimes 3-year La Ninas. And there's debate about why that might be. There's been some suggestion that the trends in the ocean temperatures over the last several decades may be preconditioning the ocean to these multi-year La Ninas more frequently now than they did before. But it's still, again, an area of active debate and intense research. So it's something that I'm sure we're going to be looking into for a while.
For sure we will. And I started off this discussion with talking about what tends to happen during La Nina winters. Emily, can you explain why what tends to happen is not always what actually happens?
Yeah, so that figure that you just were showing that illustrates the jet stream and how it tends to steer storms farther towards the northwest of the continent, and also lets some cooler air slip down. Exactly, there you go. So that is our average conditions. So if you take all of the La Nina winters that we've seen in the past and you average them together, you get something that looks like this. However, anybody who has lived for a single day in the world knows that the weather can be quite variable, and it changes a lot from day to day, and it's difficult to predict any one specific weather event. So while La Nina sets the background, sets the stage, the weather itself can still move around quite a lot, as we know.
For sure. Yes, I've learned that the hard way when trying to make these forecasts out into the long term. So along that point, Nat, is there value, do you think, because I think there is, in knowing something that will be correct more often than not, but sometimes is maybe not correct? Like, is there value in getting something right over the long term, even though we get these exceptions in these patterns?
I believe so. Even though we don't have guarantees, we know that La Nina and El Nino, they can tilt the odds in favor of one outcome over another. And there are many I think occurrences in life where just knowing that the probabilities can shift one way or the other can be pretty valuable. And I know you're a big sports fan. For example, you love the Broncos, and
Yeah.
no, you can't. We have all these advanced stats for our favorite sports and our favorite teams. We know that doesn't guarantee any particular outcome, but we know it does have value over the long haul, over an entire season, and what we can expect when we average over a sufficient amount of time.
But that's a great analogy. I mean, I don't know if the Broncos are heavy favorites going to a game. Yeah, they'll probably win, but any given Sunday, it's also like any given season when it comes to this stuff, right?
Absolutely. Yeah.
All right, love the football analogy. By the way, in graduate school, Nat played on our meteorology flag football team, and he was a fantastic receiver, very fast, very tall, able to get to those deep passes. So a little bit of information there for the viewers. All right, so moving on here. Emily, I know that you and Nat have contributed to an ENSO blog that I've read a lot. I saw that one of the most popular posts ever was how La Nina and El Nino affect snow patterns. Is there anything, specific that we could try to say about snowfall this winter?
Well, I think the example that you showed at the very beginning with the four La Nina winters, and three of them were below average and one was above average. So that kind of exactly. Thank you. This
There we
live
go.
stream
Look
thing.
at how good this crew is. You talk about something, it comes on the screen.
Yeah, this live stream thing is great. I love it. And this sort of goes to what Nat was just saying. So ordinarily, if you had no La Nina, you could flip a coin and you'd have a 50-50 chance, but being above or below average and getting it right. But here you've got a 3 and 4 chance of getting it right. So that's a pretty good illustration of that.
For sure. And, Nat, we've been talking about the winter because, the winter is probably our strongest forecasting time frame when we have La Nina and El Nino. And what happens if it's going to be neutral? What if we don't have El Nino or La Nina? Does that become more of a challenge because, okay, now we really don't have a guide to go on?
Exactly. So, when we don't have an El Nino or La Nina, then we know that the weather over a season is probably going to be dominated by some of these other factors that we cannot predict well in advance. So some of the chaotic weather that may only be predictable a week or two in advance. And so we have less of a heads up. So definitely it's more challenging from a seasonal forecasting perspective. So that's when we have to kind of hone in on these shorter time scales to understand what's going to dominate the weather over the next several weeks.
It's a great point. And I mean, not that I'm like cheering for El Nino or La Nina, but when we are in neutral years, it does make, I think, all of our jobs a little more challenging because there's just less we can say about it. All right, now we've been focusing a lot on the winter, but because we're on live stream and we have a lot of time, I want to shift gears a little bit and talk about hurricanes and hurricane seasons. Emily, how do La Nina and El Nino affect a hurricane season, especially when they're actually occurring during part of the hurricane season?
Yeah, and it's not exactly intuitive because El Nino and La Nina happen in the Pacific, and then most of the time we're talking about the Atlantic hurricane season. But what they do is they change the winds over the Atlantic. So when you have an El Nino, there's more shear, as we call it. So a change in the winds between the surface and the upper level, and that makes it harder for hurricanes to grow and strengthen. Whereas for La Nina, it's the opposite, and it tends to make conditions more conducive for hurricanes. And the peak of the hurricane season, of course, is in the fall, and El Nino and La Nina tend to be pretty well developed by then. So they do overlap with those seasons.
And to that point, Emily, I mean, when you read, the Hurricane Center make their forecast for the next season, El Nino, La Nina, usually one of the first things that they mention, right?
Mm-hmm. Yep.
Well, it's helpful, even though it's not a perfect guide, to at least have that as a guide when we're forecasting longer term weather. All right, speaking of weather, Nat, we have a situation right now of a bunch of atmospheric rivers slamming the northwest. And, you know, when we look at our map here of the weather tendencies during La Nina, it does have that blob of wetter than normal weather during La Ninas. Can we say that at least the La Nina is kind of contributing to the situation right now in the northwest?
It's certainly possible. Definitely, as you mentioned, these atmospheric rivers over the Pacific Northwest tend to be more common during La Nina. I think we tend to see a stronger signal later in the winter, January, February, but it still may be there still may be some connection now. So it would take a little bit more digging in to see exactly the role of La Nina for these atmospheric rivers, but it's at least consistent with what we would expect.
And a follow-up, Nat, I mean, when there is a lot of weather happening like the atmospheric rivers in the northwest, do you get a lot of people that come to you and say, is La Nina causing this? And is it a challenge to try to say, well, it's a factor, but it's not like all La Nina?
Yeah, it's always this sort of challenge you have when you have a phenomenon that as we talked about, can tilt the odds in favor of one outcome or another. It's often hard to make this direct connection between the two, even though what we can say is just the La Nina or El Nino. If we have an El Nino, then it might have made the outcome more likely, but establishing a distinct cause for individual weather events is a bit more challenging.
For sure. All right, Emily, I'm going to shift the visual aids behind me, and now I think this is from last year. This is from October of last year to January, and I'm drawing a box around the Nino 3.4 region, and this is just to show viewers this is what we're actually talking about for the most part when you're forecasting El Nino and La Nina, right? This area is very important. Explain that.
Yeah, it's very important. That's our most commonly used metric. So we measure the sea surface temperature, so the surface of the ocean, the temperature in that region, and we look at how much it is different from the long-term average. Long term's usually 30 years. If it's cooler than average, then it's likely to be La Nina conditions, and if it's warmer than average, it's likely to be El Nino conditions. And we look at this region for a few reasons, and the first of those is that it is fairly predictable. Our models can predict the sea surface temperature in this region 6 months, 9 months, a year, sometimes 2 years in advance. So that's pretty incredible. And then also this region has a strong relationship with impacts over North America. So there's another reason to follow this specific region.
And Emily, there are different flavors of La Nina, correct? Like you might have one La Nina that might be colder on the left side of this box or the right side of this box. So not all La Ninas look the same when we look at these ocean temperature profiles, correct?
Yeah, in fact, I think you could safely say that 0 of them look the same as any others. As they call them, flavors, so Central Pacific, Eastern Pacific, that tends to be more of an El Nino phenomenon. But yes, the location of the strongest sea surface temperature anomalies, so the anomaly is what we call the area that has the biggest difference from average, that does tend to move around a little bit, and it influences how the jet stream changes and all those play out.
And Nat, I don't know if it was in your blog post or Emily's or someone else in your team there, but I remember you wrote something about how, yes, it's important to look at these ocean temperatures, compare the values to the locations of past, so we're kind of comparing this region to itself, but it seems it's becoming even more important to see the difference between the water temperature in this box and then the warmth of the waters surrounding it in parts of the tropical Pacific, right?
Yes, absolutely. So this is becoming increasingly important as the oceans around the central equatorial Pacific start to warm even faster. So what is really important for the impacts of La Nina is that contrast between the ocean temperatures in that Nino 3.4 box that you showed and the surrounding region. So as we saw in that plot there, it was quite warm outside of the equatorial Eastern Pacific, particularly looking at the Western Pacific and even if you were to look in the Atlantic. And so that enhanced contrast between the cool in that box and the warmth has a potential to enhance the impacts relative to if you were just looking at the ocean temperature in that box. So you're exactly right. This is a contrast between the temperature in the box and the surrounding ocean that can be important for what we experience over the winter in North America.
And Emily, we don't get many tornadoes here in Arizona. Every once in a while we do, but I think I saw in a blog post that one of the most popular posts was also about La Nina, El Nino, and the relationship to tornadoes in the United States. Anything you could say about that?
Yeah, particularly in the spring, following a La Nina event or during a continuing La Nina event, conditions in the southeast, central and southeast U.S. are more conducive to tornadoes. It's a weaker link, but it does still set the stage for a more active tornado season.
Interesting. And Nat, with social media now everywhere, buzzwords are everywhere, especially weather words. Do you find that helpful or sometimes not so helpful when people are constantly talking about these terms, El Nino, La Nina, bomb cyclone? Does that make your job harder or easier? It really depends.
Yeah, I mean, it depends on how accurately, they are using these terms. And of course, when you talk about social media, oftentimes it's not completely accurate. But so the problem is it's easy to, I think, get, thrown off what the intended meaning of these terms are. But in one sense, I think it's good is that it draws attention to the phenomena. When these words, buzzwords get attention, more people have eyes on the phenomena and they do learn. So it's just the drawback is when again the information goes beyond intended meaning and there can be some misconceptions. So it's a mixed bag, I would say.
Agreed. We face the same challenges here in Arizona doing the local forecast. Emily, when you are forecasting for ENSO, do you use computer models only? Do you use history? I mean, how do you go about actually making the forecast? You sit down with a pen and paper and you look back at past seasons. You kind of know which models tend to do well in these situations, which do not?
Yes. To all of that. We do all that. So we have around 10 to 12 people, I think, on our forecast team, and everybody does something different, but we all look at some version of computer models. One of our best resources is what's called the North American Multi-Model Ensemble, or NMME, and that includes between 6 to 8 state-of-the-art computer models. It runs once a month and gives us a forecast for El Nino and various other things. And then also we do always look at the history of what's happened in the past. Another thing that we really pay close attention to is the amount of warmer or cooler water underneath the surface of the tropical Pacific, because that gives us a clue as to what direction the surface itself will be going. So there are a whole lot of things, whole lot of factors we look at when we do that.
Interesting. And you mentioned the NMME model. And for
Yes.
us weather geeks that are really into this stuff, I want to thank Nat because I actually did not work in TV a few years ago, and I had to really ramp up my knowledge on the NMME. How many phone calls do you think I placed to you, Nat, to ask you questions about that?
At least a dozen, I'd say.
Yeah. Well, I appreciate you answering those every time. All right, in the few minutes we have left, and either of you can jump in on this one, is there anything that you want to say about ENSO, La Nina, El Nino that you think people just don't understand or needs to be put out there more?
I could say something.
Go ahead.
Yeah. One thing that sometimes we get some news that says, oh no, El Nino is coming. Oh no, this is terrible news. El Nino, La Nina, they're not terrible news. They're just natural phenomena like an eclipse or some other natural phenomena. But what they do provide is they give us this early picture of conditions that we could be facing 6 months, 8 months into the future, which allows for planning and anticipation of potential impacts.
Any final thoughts from you, Nat?
I just reiterate that El Nino, La Nina, they're just one player on the field for any season. They happen to be the most predictable at the longer ranges, but these other players that can really impact our weather, they can be just as impactful. They just tend to be less predictable. So that's why, when you see, it seems like El Nino or La Nina busts, on a forecast, it's that's not unexpected because these other factors can be quite important. They just, as we talked about, just can't really anticipate them more than a couple weeks in advance.
Well, Nat, clearly you are also a football fan. I've watched a lot of football with you, and I love all the football analogies when you're describing this stuff. I think it helps a lot. Hey, Nat Johnson, Emily Becker, thank you so much for being part of Sonoran Sky Live. I appreciate it.
Well, thanks for the chance.
All right.
Yeah, it's a pleasure.
We'll see you soon. All right, so in the last few minutes here on Sonoran Sky Live, I'm going to talk about, and we'll probably stay on touchscreen because I actually want to show you a couple of past La Ninas in Arizona. So remember, I put up the Flagstaff stats, but I think it's useful to look at the entire state here. So let's start with last year's La Nina. So this is the La Nina winter of 24-25. And just so you know what we're talking about, these are precipitation deviations from average. So when you see minus and you see a brown color, that means there was less precipitation than normal. And you could see the entire state of Arizona is in brown. That means the entire state was drier than normal during last winter's La Nina. So again, that's a case where what usually happens during La Nina happened, drier than normal. Let's now go back to the La Nina before that. This one's really interesting. Here's the exception, okay? The La Nina winter of 22-23. Sure, can I expand this? Yes, I can. Okay, so you can see a lot of green showing up here, including parts of Maricopa County, Pinal County, Gila County, way above normal there with a darker green. Now, out towards Yuma and southwestern Arizona, that was really the only spot that was drier than normal. So here's the exception to the La Nina, which we can't, this is why we can't totally guarantee you a forecast for the winter because these kind of exceptions will happen. All right, let's go to the La Nina before that. This is the La Nina winter of 21-22. All right, now we're back to the rule, right? We're back to the rule of every part of Arizona being below normal. And by the way, this is a website called, it's from the University of Iowa, the Iowa Environmental Mesonet. It's a great resource, and they divided Arizona into, I'm going to call them sort of counties, because you could see Gila County, Yavapai County, Mojave County seem to be their own counties, but then looks like we're combining Maricopa and Pinal County. But anyway, you get the idea. This just shows you the breakdown of the dryness and the wetness for La Nina winters. Now let's go back to 2021. Again, drier than normal, especially here in Maricopa County. You could see well below normal during that La Nina. So if you force me into a box to make a prediction for this winter, yeah, I would lean below normal for precipitation, but definitely wouldn't guarantee it. Same thing with temperatures. I know we only have a minute left, so I'll just quickly show you this. All right, now we're looking at temperatures. Brown means warmer than normal. So the La Nina winter, last winter of 24-25, warmer than normal pretty much for all of Arizona, especially Maricopa County. But the La Nina winter of 22-23, we actually had some cooler than normal spots. Remember, this is the La Nina that was also wetter than normal for a good part of the state. So again, here was that La Nina exception. All right, thanks so much for sitting through all this. La Nina, El Nino, they're not going away. They are excellent or at least the best tools that we have for making predictions for the long term, but those exceptions will always be there. We'll see you next time on Sonoran Sky Live.